Okay, ladies and gentlemen, welcome to our third talk of the day. And this is probably our most local because Yuchi, who we're going to introduce you to, did her master's in Leeds at the university here, isn't that correct?
Yes.
Yeah. Yuchi's a geospatial analyst. She works for Lime Bikes, so I like her already. And she's going to give us a talk into how she's used data, her experience as a geospatial analyst and tools to find shared bike trips using geospatial data. Over to Yuchi.
Okay. So hello everyone. Thank you for joining this session. And I'm Yuchi Lai, and today I would like to share my project, estimating shared bike trip using TfL data and routing API. And the goal of this project is to show how open data and routing tool can help us understanding cycling in London. So this project started from my curiosity about how people move by bike in the city. And when we talk about movement data, there are several data sets that we can use. For example, the first one, the telecom location data, it helps us understanding the bigger scale of the movement in the city, and also shared mobility service data, such as if it's in London, it is like TfL Santander bike, and also Lime bike and Forest bike. And the third one is the crowdsourcing app-based data, which is Strava or Komoot. However, the first one, the telecom data, and also the crowdsourcing app-based data, is usually owned by private company and sometimes very expensive to obtain. So in contrast, the shared mobility data as more public, reliable, and provide a very useful source for analysis. And this will be the data set I use in my project. So focusing on the cycle trip in London, I use the TfL cycle hire journey data. And this scheme covers the central London, and it has 12,000 bikes and around 800 docking stations now. And it has two bike modes, the pedal bike and also the electric bike. And what can we know from this data? So in a data set, one row is a trip journey, and I can know where people travel, where is the start locations of the trip and location, and also when do people start their trip and the time duration, and also whether people are using the pedal bike or using the electric bike. This is the information we can see in this data set. But what is missing in this data set? We don't know how people, the exact route people travel, and this is the information that I really, really want to know. So this is where I use the routing API to fill this data gap. So these are the four platforms that they do provide the cycling routing for cycling. The first one is Mapbox Directions API, Google Map Direction API, and also OpenStreetMap, the OSRM, and also the Grasshopper. And the fourth, we can have the cycle route data as from Strava. And all this platform works slightly different. For Mapbox and Google Map, they use the cycle infrastructure data and try to predict the shortest path, but with different attributes. And for the OSM Grasshopper, it is more customized. You can weight different features. You can weight different features based on your analysis. And for Strava, it's not actually a routing API, but I would like to mention this is because this is the only platform they provide the actual GPS data record from the riders. So they predict the most likely route by actual data. So these are the four platforms we can have the routing for cycling, and each platform has pros and cons. But the main logic of the routing API is that they try to find the shortest path from A to B. But for cycling, routing is a little bit, for cycling, it's not only just about to find the shortest path. The algorithm also look at things like, are there bike lane, is there a steep hill, or is there a highway that the rider will try to avoid? So this kind of thing will be considered in the calculations. And for this project, I went with Mapbox Directions API using the cycling profile, and I think I really like it because it works quite really well, and it's also quite simple to use. And these are the workflow of my project. So the first step is I collect the data and do some data cleaning and join the data and fill some missing data in the data set. And the second one is I do some basic analysis to know what is the most popular stations, the average duration. And the third one is to combine the routing of Mapbox Directions API to estimate it per route and join back to the trip data set. And the fourth step is I visualize the result using the QGIS and Tableau for mapping and creating the dashboard. So all this pipeline can be reproducible, and it's all based on open source. So let's take a look at the finding I find from my project, and this is a quick overview. So I look at when people start a ride, where they ride, and also using the routing API to result to spot the gap for cycling network. And the left graph is the final result I got from the routing. Yeah, so let's look at the cycling pattern in London first. Like on average, I'm using the data in May 2025, and like there are about 28,000 trips a day, and the duration of the average duration of the trip is around like 90 minutes, and 88% of the trip are using paddle bike. And looking at the temporal patterns, like weekday is more popular than weekends, and Wednesday is the most busiest day in a week. And you can also clearly see the commuting peak, like 8 is the most popular hours in the morning, and between 5 and 6 in the evening there's another peak. Yeah, so this result clearly showed that the cycle hire is strongly tied to the commuting behavior. And also, this is the spatial patterns in London. So the most popular station is Hyde Park, and the other one is the Waterloo stations. And taking a look at the route, this is the graph that I haven't put the routing API in. So for this graph, I can see that which route taken by the most peoples. And it's quite interesting that I find out the top 5 popular route start and end at the same location, which indicate that people are using bike for leisure purpose. And if you see the circle and that is showing as the circle in the map, which means that people start their trip and end their trip at the same locations. But you can also see a clear commuting corridors, for example, from major stations, the Waterloo stations. Those for it, you can see that a lot of people start their trip near Waterloo stations. I think I cannot point the map. start from the major station and like spread it out into like other area in London. Okay, this is that image is the interactive map, and I can see zoom in and see more information about the trip, like the percentage of the total trips. And the next one is my favorite. I built an animation in Tableau that shows the activity across the day. So there's a time at the top of the graph. You can see like from Monday at 5 p.m., 6 p.m., the routes show the difference. You can literally watch the city wake up at 8, and now it's midnight. Like the city start waking up at 8 a.m. and start getting busier during 8, 9, 10, and it's quiet down a little bit during noon to the afternoon, but it peak again in the evening time, which is off work hours. And besides looking at the individual route, I also think that having the result of the total route people take, I wanted to understand about which part of the city carry the most cycling activity. So I aggregate all the routes using the H3 hexagon grids at resolution 11, which is roughly the city block level. So for each hex, I can calculate how many number of the trip passing through this area. So if I zoom into the graph, you can see that the route was covered by smaller hex, and the darker the hex is, which means that there are more trip passing through this area. After getting this result, then I thought, what happened if we compare with the pattern with the actual cycle lane network? And this is the current cycling infrastructure in London. So I overlap with the hex I got from the trips, and I only select those are in high demand area, which is the hex that has more than 30 trips per day. And here are the results that the high demand area, and it doesn't have the existing bike lane. And I really want to know, like, is this result trustable? So I go to the Google Street View and see what it looks like in the reality, and I find out these three locations are, because I cycle in London a lot, and these 3 locations I did pass through several times. And when I try to crossing the road, I have to wait on the pedestrian lane or like compete with the car. So I find it's very interesting that this analysis result did show the reality. And these are the 3 main hacks that has the most demand trips, but lack of the cycle infrastructure. And of course, there are some limitations because the road is like are inferred not by real GPS trace. So and the data only consider the Santander user, not all the London cyclists, which didn't capture all the route people would take. And another one is the routing API, similar as the first one, is rely on assumption, like the shortest path. So it might not exactly 100% match what the riders actually choose. So the result of the guide not absolutely true. Yeah, so to wrap up of this project, I really want to try to do this project because I was wondering, is it possible to use only open source and open data without GPS to learn about the cycling pattern? And by combining open data, routing API, and spatial tool, we can uncover the pattern, hotspot, and gap in the cycling network. Yeah, and hopefully this project can support a better planning and more sustainable mobility in the city. And thank you very much. I hope you enjoyed the presentations.
Thank you so much, Yuchi. Do you know what I took from this presentation, apart from the fantastic conclusions that we need more cycling infrastructure in London? What I took from this is the tenacity of geospatialists. Yeah, whenever we're faced with data and it's not there, we always find a way, don't we? Even if it's proprietary and we can't have access to it, we find another mechanism. So well done, that's great. And we've got time for a few questions.
Yeah, so my question is about the routing API. So how cost efficient for a project would be using a private API like Mapbox or Google when you have millions of routes of commuters going to A to B and predict patterns, taking into consideration that each call potentially have a cost. So that leads toward using mostly open source data, OSN data, or self-hosting routing engines.
To summarize the question, I think you're saying how cost effective is it in a project like this when you're having to call potentially paid APIs versus using open source data such as OpenStreetMap?
For the Mapbox API I currently use, I didn't spend any money on it because the good thing is because the TfL bike is the dock stations and it's like 800 dock stations. So the total of the route will be 800 times 800, like 64,000 route in total, the most. And I checked the data set. It's only like 40,000 route in total in reality. So that is below the amount, the cost amount in Mapbox API currently, yes. And
you talked about Strava and how it isn't indicative of just commuters, but have you considered filtering the Strava data for the commuting types, then using that as almost a pseudo-truth data set? Because a lot of people will commute with Strava on, not just in leash mammals in Lycra, but mainly.
The question was, could we use the Strava data by filtering it down to commuter times to give us what we think would be indicative commuting routes rather than just looking at the whole data set?
Yeah, I think that is possible because actually Strava data is like compared to the other three platforms, only Strava is using the actual GPS data from the riders. So I think that is the quite trustable data source.
Thank you so much. It was really interesting. I was just wondering if you had any plans to extend the analysis or run it again. So it'd be really interesting to see, I guess, if you run it on different time periods, so the recent strike activity in London, to see how that would affect it. Are you going to rerun it because you mentioned it was kind of a reproducible pipeline? Or are you going to kind of overlay other data on it? You're going to look at maybe, I guess you could look at those interesting 3 points that you pulled out at the end where there aren't any cycle lanes at the moment and look at accident data as well.
The question was, are you planning to rerun the study in the future against other conditions such as strikes that have happened and other changes?
I think something I can do more about this SAM workflow, SAM data set is now I'm taking a look at the entire London, but if I want to know where exactly the rider starting from Waterloo, where did they go, I can filter the data, only focus on the trip that start from Waterloo and also create a graph like this so I can exactly know where do they go. And also I did really want to do the analysis during the strike time because there's a big strike on September 14th that week. But Unfortunately, that data set is not available right now. I try to like see what's the pattern. Is it more trip during that week? But yeah, I would definitely want to do the analysis when the strike data is released on a TfL open data.
One final question.
Your analysis shows on a particular day, on a particular hour, a certain number of cyclists going across Waterloo Bridge. If you considered going to Waterloo Bridge one day, count the cyclists on Santander bikes, and then wait for your analysis to come 3 weeks, 4 weeks later, and see if they correlate.
The question there was, has Yuchi looked at comparing the data that she's extrapolated from her study with real live data, specifically at Waterloo Bridge, to see if they correlate?
That's a really good question. And there's another data set that I haven't had time to combine with my data set. As TfL do put some counting point in London, like in Embankment, and the other, I forgot what's the other locations, but they do counted the how many riders go through that location. So I think that would be a really, really good data set to evaluate whether this routing API worked well or not. Yeah, I think this is also I really want to do in the future of this project.
Thank you so much, Yuchi. That's our appreciation once more.